This is going to be a short lesson on solving algebraic equations. Let's start with some pretty simple ones. If we had x plus 5 equals 10, you could probably figure out that x would have to be 5, because 5 plus 5 is 10. But let's see how we could solve this algebraically. We need a number plus 5 to equal 10. So in your mind you might go through numbers to plug in here. Or you might think, well, 10 minus 5 is 5, so that means x has to be 5. And that's how we're going to do it algebraically. What we're going to do is use inverse operations to get x by itself, but you'll see, really we're going to do 10 minus 5. So here we would have a number plus 5 equals 10. So we're going to subtract this 5 from both sides of the equation. It may be useful to draw a line through the equal sign and down, because this way we remember, whatever we do to one side of this line or one side of the equal sign, we have to do to the other. So 5 minus 5 is 0, so that's just gone. I'm left with x on this side. And 10 minus 5 is 5. So we find that x is 5, but again, we probably could have just figured that out without doing any algebra. So let's just go through some more examples. X plus 8 equals 30. So we'll draw a little line, and we want to solve for x. So because we're adding 8, we'll do the inverse and subtract 8 from both sides. So that's gone, and we have just x on the left side. And 30 minus 8 is 22. We have x minus 3 equals 7. We'll draw a line. Alright, to get rid of the minus 3, we'll add 3 to both sides. So we have x. 7 plus 3 is 10, so x equals 10. And also we'll do negative 4 plus x equals 12. Alright, so here you may look at and see that this is negative 4 plus x. So to get rid of the 4 here, the negative 4, we should subtract the negative 4. But think, that's not going to cancel this out. Negative 4 minus 4 is negative 8. We want to get rid of this term. So what we should do instead is add 4 to both sides. Now that's gone. And we have x on the left side, and 12 plus 4 is 16. So x equals 16. Let's look at some examples involving multiplication. So for example, if we have 3x equals 12, that means 3 times some number equals 12. And again, you could probably figure out that 3 times 4 is 12, so x must be 4. But let's just go through this. We'll draw the line down. And the inverse of multiplication is division. So we'll divide both sides by 3. That'll cancel out this 3, and we'll have x. On the right side, 12 divided by 3 is 4. So we see that x equals 4, much like we already knew. Some more examples. 2 times x equals 30. Alright, to get x by itself, we have to do the inverse multiplication, which is division, on both sides. And we get that x equals 15. Let's have 5 times x equals 25. Let's take a look at this one. Draw our line. We'll just divide by 5 over here because, of course, our goal is to get x by itself. And divide by 5 on the right. And we have that x equals 5. In this example, negative 3x equals 18. Draw a line. Don't be tricked by this negative. Don't think that this is subtraction. Okay? The operation that exists between the negative 3 and the x is multiplication. This is negative 3 times x. So to get rid of negative 3, we have to still divide by negative 3. And of course on both sides, 18 divided by negative 3, negative 6. Now look at some examples involving division. X divided by 2 equals 8. So this is x divided by 2. So we have to do the inverse of division, which is multiplication. So we'll multiply both sides by 2. Those cancel, and we get x equals 16. Okay, let's also try x divided by 3 equals 5. So x divided by 3, the inverse of dividing by 3 would be to multiply by 3. And we have to do that to both sides of the equation, of course. So we have x equals 15. There's another method for solving equations that involve division. You may have seen this before, and that's called cross multiplication. So in this case, we'll try cross multiplication here. It's important to write both sides as fractions. So 9 is really 9 over 1. So we're going to do 36 times 1, and we get 36. Then 9 times x, and we get 9x. Okay, at this point, we have 9 times x equals 36. So still, we want to isolate the x. So we should divide by 9. And we have 4 equals x. Okay, we'll just go through this now without using cross multiplication. So if we had 36 over x equals 9 times, or just 9, because we actually added that, equals 9. Right, this is a little different because now we're dividing by x. Even though we want to get x by itself, we don't want x to be in the denominator. So let's get a numerator by multiplying both sides by x. So here they cancel. I have 36 equals 9x. Very similar to the method of cross multiplying. So again, we just divide by 9, and we still find that x equals 4. So both of those methods work. So for simple algebraic equations, we're just going to do inverse operations to get the x by itself.